Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Alright, hello and welcome. This is my lab review for our lab 11.10.1. It's a packet tracer for designing and implementing a VLSM addressing scheme. So this is for CCNA1-ITNv7. This is one of those labs where you will pull your hair out and get frustrated. Not because it's a complicated lab, it's mainly because the QA on this lab is so horrible that I don't understand how we are allowed to even get this published. So, first of all, things that I'm circling, all of this can be modified. Every time you open the lab, you'll get one of 3 different scenarios. To make it even more complicated, each of the scenarios have correct host counts, or maybe not have correct host counts. So what I mean by that, I've already done separate videos on explaining how to verify if this is valid or not. The names are irrelevant. It could either be police, school, HQ, remote, or some other variation. Every time you open the file, you may get a new scenario. The names may change. Ignore the names. The names don't mean anything. I want to point out that this is the left side, this is the right side. So, the scenario is based off of the IP address. This happens to be scenario number 3. That IP address, 192.168.203.0, will be the one that denotes scenario 3. Again, I've done separate videos on scenarios 2 and 1. So once you figure out what scenario you're working on, again, the names of the devices are irrelevant. What you need to look for is on the west or school or remote on the right hand side, on the second switch, is there 32 hosts? Because the network might look like this, it might look like this. There's multiple variations of this. Basically, if you're looking for the second switch on the right hand side, if that one has 32 hosts, it's good. We can proceed forward. If it doesn't have 32 hosts on the second switch, and that is the scenario 3 IP address, close it, just get a new one. I've done separate videos on a invalid scenario 3 where it was actually 19 hosts on top and 32 hosts on the bottom, and there was no way to pass this because the grading for this assignment is based off of if it's scenario 3, 32 hosts on the top. I wish I could say that that was where we could table this and it wouldn't be as complicated, but it's not. The QA on this is pretty horrible, so we're just going to run through it the best we can and go from there. So, IP 192.168.203.0, that's scenario 3. Second switch is 32 hosts. That means this is a valid network, so we can move forward. So here is the address chart that was provided to us in the packet tracer. Well, I don't know if you guys spotted it, but WS2 LAN has 32 hosts. The address chart shows 19. They flip-flop these addresses. Again, bad quality control. So I'm going to be referencing the diagram. That's how I come up with my numbers. So, the right-hand switch, whether it is west, whether it is school or remote, does not matter. We're going to be ranking these based off of what side they're in. The highest number in this chart is 32. So we're going to do these two guys first. West switch 2, west switch 1. I understand this is not what you'd be doing in real life. I've done separate videos on explaining how to do subnetting. However, in order to get the grading on this packet tracer done, you got to do it their way, and their way is beyond incorrect, but I'm just working with what I have the ability to work with. So switch 2 is 21 and then 14. So this is the pattern we're going to be following. Yes, I understand. Normally we would do greatest to least. However, again, messed up packet tracer, so I'm just going to keep apologizing for it and keep going forward. I understand that the numbers don't line up to the packet tracer. Again, we're lining everything up. I'm ignoring the host requirement. I am looking at the diagram and looking at the host count. That's how I'm coming up with the numbers. Alright, so I'm going to move forward to at least the next chart. Next chart, again, I'm just working through the worksheet. I'm going to work through all the addressing, then we're going to do the packet tracer. That way you can see step by step what I'm doing. So, to fill out the address chart, again, we just take the same information we did. It's not letting me grab my pen. Let's try that again. Alright, so 32, 19, 21, 14, 2. Remember that we have two routers, so we have to accommodate for those two addresses. But we also have an ID and a broadcast, so that's another 2. So we actually need to add 2 to all of these to accommodate for the ID and broadcast, because all of these are usable addresses, meaning we need that many devices. We also still have to accommodate for the ID and broadcast. Alright, so again, label all of this so it makes sense. East switch 2, east switch number 1. Interconnect. Again, normally I'd rank them greatest to least, but again, I'm just working with what I have. I'm double checking 32, 19, 21, 14, 32, 19, 21, 14, and 2. Alright, so we are good. So next, to figure out the rest of this, how do we get the network and CIDR? How do we get the usable and broadcast? Well, we actually need to build out an address chart. That's what this guy's got to be. First one is hosts, subnets, our grouping, our ID, start range, end range. Remember, this is a number line, so start through end. broadcast. And because of how screwy this one is, I added in an additional column for the network name. Alright, so hosts 32, 19, oh, nope. We don't need usable, we need total. 34, 21, 23, 16, and 4. This is going to be total hosts. Subnet and group we will handle in a minute. We were given an address to start off with. This is 192.168.203.0. We're going to build off of this address. Next, again, for naming sake, west switch number 2, west switch number 1, east switch number 2, east switch number 1, interconnect. Because of how screwy these scenarios are with bad QA, I'm trying to be specific. Alright, so we're going to do the first network, 34. We need a total host count of 34. I'm going to build out my subnets based off of our octets. You guys should be familiar. Each octet is 8 bits. Four, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Fourth, third, second, first. Most of what we're going to, no, all of what this lab is going to be doing is going to be in the 4th octet. If our host count is between 0 and basically 255, it's going to be in the 4th octet. If our host count is between 256 and, you know what? I'm going to give you accurate numbers. Give me 1 second. Alright, so this is between 256 and 32,000. This is between above 32,000 through a cool mill, it looks like. So in reality, most of what we're going to be doing is in the 3rd and 4th octet. And in reality, for these labs, we are focusing just on the 4th octet. So that means we need a host of 34, 4th octet. We need a host of 21, again, 4th octet. All of these are going to be 4th octet in this lab. I've done separate videos explaining how to do the multiple subnets, VLSM in the 3rd and 4th octet and things like that, so I'm not having to redo those. So actually I'm going to go ahead and erase the screen. Again, we need a total host count of 34. We know we're working in the 4th octet. 1, 2, 3, 4, 5, 6, 7, 8. I don't know why I did that. Let's just add 2 more to this side. So 1, 2, 4, 8, 16, 32, 64, 128. Again, the 3rd, 1st, and 2nd octets are all still there. We're just not writing them out. So, because we're dealing with the 4th octet, this is going to be our host count and our grouping. How do we get the numbers? We're doing with binary. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. So that's how we actually got the math. They're not just randomly doubling. We have to have a structure for this. We're starting on the far right side in the 1 position. Question we're trying to answer is, if we need 34 hosts, does the 1 position give us 34 hosts? Well, 1 does not equal or is not greater than 34, so in this position the answer is no, it does not. In the 2 position, does that give us 32 hosts? No, it does not. In the 4 position, does that give us 34 hosts? No, it does not. In the 8 position, does that give us 34 hosts? Again, no, it does not. Does 16 give us 34 hosts? No, it does not. In the 32 position, does that give us 34 hosts? Close, but no, it does not. Now remember, our original was 32, and then we added 2 for the ID and broadcasts. If we didn't add 2 for the ID and broadcast, then that would have worked. However, we needed 32 usable addresses, plus we had to accommodate for the ID and broadcast. So that's how we got our 34, and that doesn't work. So now we can double check. Yep. Does 64, does the 7th spot give us 34? Yes, it does. In fact, I don't know why I did that. I'm just going to do a 1, boop. And that means all of the ones to the left of that are doubling, so they're all going to accommodate 34 because they're all bigger. Remember, there are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. In the first, second, and third octet. So, if we count out all the 20 or all the ones, that is a /26 or a 255, 255, 255.192. So that's the subnet. So then we had the next question of what is our what is our grouping? Our grouping is the last one on the right side. So that will be a group of 64. So I'm going to go back to my address chart. Subnet is a /26 or 255, 255, 255.192. Group is 64. I will explain the group when we finish the address chart, but we've now completed the subnet and group for that network. Next, we're going to do our next network, West Switch 1, with 21 total hosts. I'm going to reuse this chart, so I'm just going to erase these details. We need 21. Same process. We just rinse and repeat. That doesn't give us 21. That doesn't. That doesn't. That doesn't. That doesn't. This does. So, again, 16 is slightly too small. We need a 21. Doesn't fit for 16. The next number is 32. Yes, that's over, but that's the smallest one that we can accommodate 21 total addresses. Grouping is 32. Subnet is /27. Again, 8 ones, 8 ones, 8 ones, 25, 26, 27. Or a 255, 255, 255.224. 128 plus 64 plus 32 is 224. Again, I've done separate videos explaining the binary math, so I'm not focusing on that. 32 /27, 255, 255, 255.224. We could do the exact same thing for /23, but the math is already here. Again, 23 is greater than 16, 23 is less than 32, so it's the same thing for 23. I just didn't want to erase everything and redo it because, again, it's the exact same. Subnet, all those details. /27, 32, 255, 255, 255, 224. All right, next network is 16. Since that is a different number, I'm going to erase everything, and we're going to go through the number again. Again, the assumption is they've accommodated for growth, and that's the number we were given. So, we need 16 total hosts. The 1 spot gives us 1, the 2 spot gives us 2, so none of these give us our 16 hosts. This does. 16 gives us 16 hosts. However, if any new devices are added, it doesn't work. But that was not our concern. Our schedule showed we needed 16 devices, or 14 usable devices plus an ID plus a broadcast. So that's what we are going off of. Grouping is 16. Subnet is a slash. 8 plus 8 plus 8, that's 24. 25, 26, 27, 28. So it's a /28. We're at 255, 255, 255, 128 plus 6, or 128 plus 64 plus 32 plus 16. 240. 16 /28. 255, 255, 255, 240. All right. So, last network is our interconnect with 4. Let's get these erased. Let's run through the problem one more time. Total host of 4. 1 doesn't, 2 doesn't, 4 does. Boop, 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 boop. That's a /30. That's a grouping of 4. That's a 255, 255, 255.252. Sorry, my keyboard went forward instead of backwards. /30. 255, 255, 255.252. All right, so now we can get to the start. Now that we have our subnet, our groups, we can start building our address chart. So that is, we start with 192.168.203.0. We are working in the 4th octets. We are adding 64 in the 4th octets. 0 plus 64 is 64. First network ID, done. We go to the next ID. We're still working in the 4th octet. We are adding 32 to the 4th octet. Again, we're building an address chart. So we're building off of an existing number line. So the order does matter. Next one. Again, we're adding 32 in the 4th octet. All right, now we're going to the 4th network, also in the 4th octet. We are adding 16. 128 plus 16. 244. Double check my math. 8 plus 6 is 14. Carry the 1. That would be 144. I can do math. All right. Next one. 5th network, our interconnect. We're adding 4. 192.168.203.148. All right, so that's the start of our address chart. Now we can fill in the rest. Alright, so now we can start with our IDs are done. We can go to our broadcasts. Our broadcast is 1 less than the next ID. So you're going to notice 192.168.203. Those are all still going to remain. I'm just going to stop writing them so that we don't clutter all this up. So 1 less than 64 is 63. Again, we're in the 4th octet, 192.168.203.63. And we're going to follow the same logic all the way down. Again, this 4th octet. All right. Again, all of them still start with 192.168.203.0. Or, sorry, 192.168.203 dot something. The dot something is what I'm writing out. So, our start and end range is everything in the middle. So, what is between 203.0 and 203.63? Well, the nice thing is we can start with 1 and we can go through to 62. So that's 1, 2, 3, 4, 5, 20, 30, 40, 50, 60, 61, 62. After 62, it goes to the broadcast. So what is between 64 and 95? 65 through 94. Again, 192, 168, 203 is still there. I'm just only writing the 4th octet. What is between 96 and 127? What is between 128 and 143? What is between 144 and 147? And again, the bottom one is left for growth. Just like we started our chart with 192.168.203.0, this guy right here is growth. So, Network 5, the interconnect, it only has 192.168.203.145 and 203.146. Only 2 addresses. Is that good enough? Yeah, because we only needed 2 hosts. And then we needed an ID and a broadcast. So we have our 4 addresses. So yeah, that does accommodate what we need. So we need to ask some other questions so that we can complete our packet tracer. We have an address chart. And in that address chart, we have details that we have to fill out. So we have to work through this. On my chart, I don't have the devices. I have a spot to write them in. And I did that on purpose because, again, the bad QA here just made this hard. I'm going to look at these questions at the end to be able to fill out my address chart. So to do that, assign the first usable IP address in the appropriate subnet to east for the 2 LAN links and the WAN link. First usable. Assign the first usable IP address in the appropriate subnet to west for the 2 LAN links. So, the big one that I want to point out, WAN link first usable, that will be the 145. Last usable for the WAN link is 146. So we have that. And then we can do the other addresses as the first usable for the WAN links, i.e. the router address. Second usable will go to the subnet to the switch. That would be the SVIs or the VLAN 1 interface. I can spell. Again, switch should be reachable. Last, assign the last address to the appropriate host. So I'm going to go back one slide, and we're going to work on filling out this chart. So what I did was, to make this easier for me, I took our address chart, took a snippet of it. It's off my screen so that I can fill out this address chart. Alright, so first things first, our devices are going to be, what did they want us to do? WAN link for east and west. East, west. IP address, LB 192.168.203.145. And then the next one will be 192.168.203.146. I'm going to do the slash numbers. Again, we've already done the subnets, so you should understand how to convert the slash numbers to dotted decimal. So I'm not going to get too hung up on that. Alright, so we have gig 00 and gig 01. Well, which one is which? They don't really say, so I'm going to mouse over. Gig 01's on top. Gig 00 is on bottom. So gig 00, that would be for our east switch 2. I want to double check the addressing just to make sure. Alright. That's going to be 129. And this one will be 224 from our address chart. 203. 2.168.203. Remember that we were looking for the first usable $129. Oh, 97. What did I do? Oh. Nope. Why are you going for it? 97. And then again, make sure to do the appropriate subnets. I'm having to go back and forth just to double check, because again, I've had this one get all types of screwy. So, all right. So 129, our subnet was a /28, and again, this one is going to our ES1. This is going to ES2. And how did we rank these? West switch 2, switch 1, east switch 2, east switch 1. Alright, so, and then this guy with a 97 is a /27. East switch 2, its broadcast, or sorry, its default gateway, i.e. the router address. East switch 1, right. And according to the instructions, assign the last usable IP address to the appropriate hosts. So switch 2 and switch 1 /28/27. Last usable for east switch 1 is 126. Double check. East switch 2, last usable, perfect. East switch 1 is 142. 192.168.203. 68.203. So again, how did I come up with that number? Switch 2, last usable. Switch 1, last usable, 128, 142 are subnets. First usable for switch 2 is 97. First usable for switch 1 is 129. So that's how I'm able to populate these details. Alright, next one. West switch 1, west switch 2. Alright, west switch 1 .65.1. Switch 2's network, that's going to be the larger network, .1. The one that's attached to switch 1, that's going to be .65/26/27. /27/26. to 168.203. Alright, switch 2. We know that's a /26. We know that the gateway is 192.168.203.1. For switch 1, we know the gateway is 65. 192.168.203.65. That's also /27. Last usable address. 192.168.203.62. Again, I'm pulling that from the address chart. And then the one that's attached to switch 1, that will be .94. I don't like that space, so 62, not 32. Alright, now we have our PCs. And our PCs, I'm going to keep the same structure. West switch 2's PC is W287. Then W1 201, East 2, East 1, alright, so this is second usable. Looking at switch 2, we assigned switch 2, that's this interface right here. First usable was given to the IP address. The first usable was given to the default gateway. IP address 192.168.203.1. That's going to be the gateway. That will be a /26. Second usable, well, what comes after 1? .2. So 192.168.168.203.2. Alright. West 1, switch 1. That'd be that guy. The IP address for the gateway is 65. 192.168.203.65. Subnet /27. Second usable, well, if the first usable is 65, the second usable will be 66. Alright, East switch 2. That'd be on the gig 01 interface. The default gateway is 192.168.203.97. That's the first usable. So the second usable would be 98. 192.168.203.98. And the subnet will be a /27. Alright, last would be the East switch 1. If we're looking at the router, the IP address is 192.168.203.129. That is the default gateway for that network. 129, that's a /28. And the second usable address, since 129 is the first usable address, 203.130. Alrighty. I do believe our address chart is complete. I want to double check, so I'm going to pause and I'll be right back. Oh, actually, I did a little bit of a boo-boo. I read the instructions and I kind of screwed up. I did the second usable to the host and the last usable to the switch. So this one is currently, I'm just going to do the third octet so I can make these changes real quick. So this one is 62, this one is 94, this one is 126, this is 42, 266, 98, 130. I messed up. That should be 130, 98, 66, 2. Again, I flipped them. I did last usable for the switches, and I did not mean to do that. 62, 94, 126, 142. Alright, just to double check. So, last usable goes to the host. Second goes to the switch. Alright, so I'm going to run through these just to verify one last time. East switch 1 is attached to East switch 1. First usable is 128. Second usable is 130. Last usable is going to the PC. East 122, 142. That is correct. So again, just double check all of the addresses and you should be okay. I do want to 26. Everything looks good. So now we can jump in and start doing the configuration. Alright, so now that we've done this, we can now get in And we can now start programming our packet tracer. So this is what gets real fun. Alright, so I'm going to hop on East, switch 2. Alright, the East router, not East switch 2, but the East router. Switch 1 and switch 2 are attached to it. So East router, enable, configure terminal. First, interface, gig 0/0. Again, I'm just programming the addresses based off of the address chart that we built. 192.168.203.129. Subnet 255.255.255.240. No shutdown. Oh, no shutdown. Alright, we'll go to interface gig 0/1. IP address 192.168.203.97. Subnet 255.255.224. No shutdown. Exit. Interface serial 0/0/0. IP address 192.168.203.145. Subnet 255.255.255.252. No shutdown. Alright. East router done. Again, all I did is I'm just working down line by line by line. Just working down the lists. West router. Enable conf t. The nice thing is I just took a screenshot of that. I just have it off to my side and I'm just working through it. Interface. Alright, interface gig 0/0. Make sure to do a space. IP address 192.168.203.65. 255.255.254. No shutdown. Interface gig 0/1. IP address 192.168.203.1. This is the large network. 192. No shutdown. Alright, now our serial interface. Serial 0/0/0. IP address 192.168.203.146/30. No shutdown. Alright, the two routers are now completed. Check results. I've not done machines. I've done the East router. All of those showing checkboxes. The West router. All of those are showing checkboxes. Perfect. I've learned with this lab that do a device, check. Do a device, check. Because, again, with how bad a QA with this lab was, it just makes things more complicated. Alright, so I'm just going to start with switch 2. East, switch 2. Enable conf t. Alright, interface VLAN 1. IP address. Alright, this is E switch 2. This should be 192.168.203.98. Subnet mask 255.255 dot, this is 98.224. No shutdown. Alright, it took it. East switch 1. Enable conf T IP address east switch 1 192.168.203.130. Subnet 255.255.255.240. Oh. IP interface VLAN 1. Now we type the IP address. You cannot type an IP address on a switch. You have to give it to an interface. A specific switch interface like FA01 is not one that can receive an IP address. For a layer 2 switch, you have to navigate to a VLAN, a virtual interface, to assign an IP address. No shutdown. Alright. Those two switches are now complete. We'll go over to switch West switch 2. Enable conf T interface VLAN 1. IP address 192.168.203.2. Subnet 255.255.255.192. First octet, second octet, third octet, fourth octet. Alright, perfect. No shutdown. Alright, switch West switch 1. Enable conf T interface VLAN 1. IP address 192.168.203. So this is West switch 1.66. Subnet 255.255.255.224. No shutdown. Alright, so we've done everything but the computers. Again, I'm just working down my list of addresses. East. Computer 1. Whatever device is attached to switch 1 on the left side. Again, your names might be different, so what's really weird is sometimes you get a default gateway that was populated, and that is just a random, really weird bug. 203.142. 255.255.240. I'm going to keep doing the same numbers over and over, so I want to highlight them. So this one would be 129. The last, the PC is the last usable, which will be 142. The default gateway is the first usable, and that network would be 129. Alright, perfect. E2, or the PC attached to the left switch, number 2. Configuring the PC. Alright, so that'll be 126. Last usable in the third network. This will give us 255, 255, 255, 224. Default gateway. First usable, 97. Alright. PC is done. PC is done. Now we can go to the right side. I'm going to do the right switch attached to the right switch 1. Okay, that was a little weird. Alright. Right switch 1. For this one, that would be W1203. W.94. Subnets. 255, 255, 255, 224. Our gateway address is .65, last usable. Last PC, it's PC number 2 attached to switch number 2 on the right side. So this would be W287. That would be 192.168.203.62. Subnet 255, 255, 255.192. Gateway will be .1. I have a 90% completion. I'm going to check my results. Assessment items. East 1. East 2. West 1, West 2. They're showing default gateway on the switches not configured correctly. I don't remember. Assign the first usable on the east and west link. Assign the second usable for the appropriate subnet. Switch management interface should be reachable. Last. Alright, I do not see any instruction stating to assign the default gateway to the devices. So, that's alright. We'll go to switch 1. We'll just do it again. Exit. Alright, it'll be IP DE. That'll be for default gateway. I'm doing switch east 1, which will be 192.168.203.129. I'm going to move it so that you can see the completion rate. Alright, perfect. East switch 1 is done. East switch number 2. Exit IP default 192.168.203. This is east switch 2.97. Alright, west switch 1. Exit IP default gateway 192.168.203. West switch 1 is 65. And the last guy, exit IP default gateway 192.168.203.1. 100%. Again, this is the type of lab where you have to verify that it is completable. I've encountered several scenario 3s where the addresses are flip-flopped and they're not completable. Alright, so this is now showing 100% as opposed to 8%. The invalid one you cannot complete because the host counts are incorrect. Literally, the addressing for each device is the grading. And if the hosts are flipped, and this one is expecting the network that gives you 32 hosts, and it's not listed as 32 hosts, it doesn't work out. Questions, thoughts, or concerns, please feel free to reach out. Thank you. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.